Today in 8th grade, we're going to be working on graphing equations that are in what we call slope-intercept form. Now, we've already been working on slope. We know that slope is the change in y over the change in x, or it's the rise over the run. We've been able to find that slope when we're given 2 points and plotting those. And we've also been able to write an equation from a t-chart by plotting points. Well, today we're going to look at something that really is interesting that happens when you write an equation that's linear from an ordered pair, and we're going to call that the slope-intercept form. There are actually 4 different ways that you can graph equations. We can make t-charts. That's kind of like your input-output, where you had your x, your rule, and then your y. We've done those, and then we plotted the ordered pairs. Okay, we can also find the change in y over change in x. That's also from given pairs, and that gives you your slope, or we often call that m. Now today we're going to look at the slope-intercept form. The slope-intercept form is when you have y equals some number times x plus another number. That's going to be your rule. And in that rule, when we were working with our slope, we found some interesting things happen. In our rules, that whatever we were adding or subtracting over here happened to be where it crossed the y-axis. That's why we call it the y-intercept. The y-intercept is where it crosses the y-axis. That's called the y-intercept. Okay, then whatever is in front of x, or you're multiplying by x, is going to be your slope, or that's what we call an m. And then we're going to look at a 4th way later on. That's with the x and y intercepts, and we're going to talk about that later on, the cover-up method. So let's take a look at what I'm referring to. We have an equation. This is a linear equation because I have 2 variables involved. We can make a t-chart. We can plug it in, and we can put in values for x and get values for y. We can do that. And when all else fails, this is something that you could always try. Now, what values do we plug in for x? Well, it doesn't matter as long as you have some positives and negatives. I usually put in a 0. So what's 3 times a negative 1? Okay, negative 3 plus 2 would be a negative 1. And what about 3 times 0 plus 2? Okay, 0 plus 2 is 2. And then a 3 times 1, which is 3 plus 2, which is 5. Okay, so we can plot these ordered pairs, negative 1, 0, 2, and 1, 5. So let's do that. Negative 1, 0, 2, and 1, 5. And we can draw our straight line. Now, once I do this, I'm going to make some observations. Okay, we notice that where it crosses the y-axis is 0, 2. We notice it has a slope of rise over run 3 to 1. So your slope is 3, or 3 over 1. Now let's look at our equation. We had y equals 3. Oh, this is the 3. This is your slope times x plus, and this was 0, 2, your y-intercept. Okay, so from that, we could have taken a shortcut rather than make this t-chart. We could have had a shortcut, and I'll show you how to do this, in which we are actually going to graph our equation just giving this information. We can identify our slope is 3, and our y-intercept is 0, 2. Or we often call this the B. Now, when you start to graph, that's your first step. The first step is to graph the y-intercept, or that point. Okay, so let's do that. We start with the B, or the y-intercept. We're going to graph 0, 2. You have to start with it first. Okay, then the second step is to plot second point, because it always takes at least 2 points. using the slope to help you get there. Or we're going to call it our m. So from this point, my pencil's here. I know I have a slope of 3, so that means I go rise of 3, 1, 2, 3 over 1. Rise 3 over 1. And I can continue that. Or if I go a negative 3 and a negative 1, that still makes it a positive move. Two negatives make it a positive. And I can just continue plotting those points. And each one of those would fit into my rule or my t-chart and give me that correct value. So this is the graph for y equals 3x plus 2. But it's a lot quicker to do it that way if you identify the y-intercept first and plot it, and then the second point using your slope, than it is to actually make a t-chart. All right, let's try another one. We have the equation y equals negative x plus 2. Let's first identify what your slope is and what your b or your y-intercept. Okay, so what is your slope? Remember, it is y equals mx plus b. That's your slope-intercept form. We always are looking for whatever's in front of the x is your slope. What number is being multiplied by x? Oh, you don't see one? Well, there's a negative, but remember what's that invisible man in front here? It's actually a negative 1. So your slope is going to be a negative 1. Okay, what's your y-intercept? Okay, it's the 2, or we write it as an ordered pair, 0, 2. Remember, it has to be on the y-axis. All right, what is your first step in plotting this? Trying to graph your equation. Right, you start with the y-intercept first. Got to plot that point, 0, 2. Okay, and then what? Okay, the second step is to plot second point. But how do I do that? Using your slope, correct. All right, so from this point, I'm going to go down 1 and to the right 1. Down 1 to the right 1. Down and positive. A negative, a positive makes it a negative. Or I could have gone up and then negative, positive and negative, and then connect those points, and you've just graphed that equation. And that's a lot easier than making a t-chart. So that's just another way of doing it. But it has to be in this form in order for you to do it. And that's called slope-intercept form, like we have in our notes. Okay, if we want to graph this one, it's not in nice form, is it? No. So we need to rewrite it so that it is in slope-intercept form. Okay, made a little switch here. Let's try this one. We have 4x minus 2y equals 16. We need to get y by itself. So as an equation, I need to move everything to the other side. I'm going to do so by getting rid of the 4x, just like when I do an equation to move anything to the other side. I do its opposite, and I'm left with negative 2y, because this is all gone, equals a minus 4x plus 16. Now I put the x term first because it's getting close to that y equals mx plus b, or that slope-intercept form. Okay, now I want y by itself, so I still need to get rid of the negative 2, and you do so by doing the opposite of multiplying by negative 2, and that would be divide by negative 2. So that I have y is equal to, now over here you must divide both terms by negative 2. What's negative 4x divided by negative 2? A positive 2x, great. And then a 16 divided by negative 2 is a negative 8. Okay, so now it's in slope-intercept form. I can graph it because I know the slope is 2, and the y-intercept, or your b, is going to be 0, negative 8. So my first step, start with your b. 1, 2, 3, 4, 5, 6, 7, 8. And then I get my second point by using my slope, which is 2. Means I go a rise of 2 over 1, a rise of 2 over 1, and so forth. And I have just now then graphed this equation. So what you're going to do today is you are going to be given slope-intercept form, and then you're going to graph an equation using what you know about the slope and the y-intercept. And then we're going to have some other equations in which I just want you to get practice of solving for y, like we did here. Okay, today we worked on graphing a linear function or equation using the slope-intercept form.